Alright, so I would like to balance another equation a little bit more difficult this time. This compound, C8H18, 8, we say octane. This is the fuel in your gas tank. So octane, carbon source, plus oxygen in the atmosphere. This is a combustion reaction. Right? This will combustion always gives us carbon dioxide and water. Alright, so again, the first thing we always do is list the elements. Fine, we have carbon, hydrogen, and oxygen. There's a few hints or tricks to doing these that we haven't seen before. Next thing we do is we determine the number of atoms of each element in both the reactants and products. So for carbon we have 8, we've done this before. Here just 1, not balanced. Hydrogens we have 18, again put it right below the hydrogens. And the water we just have 2, not balanced. These numbers are going to be a little bit larger. Don't let that intimidate you. For oxygen, again we're going to put the oxygen number here, 2 atoms of oxygen right below the oxygen. This is one of the, it's actually not even a trick or a hint or anything, it's something you must do. We have oxygen in both carbon dioxide and water, and we must keep them separate. So yeah, we have 2 here and it's 2 plus 1, but we have to keep them separate. So I'm going to write here 2 oxygens in CO2 plus 1 in water. And you'll see why this is very important in a moment. Alright, so determine the number of atoms, and a little hint here. If an element appears in more than one substance, and again in this example here, oxygen is appearing in both carbon dioxide and water. And the reason I use the term substance is because oxygen is an element, carbon dioxide and water are compounds, so I can't just say element or compound. So a substance. If it appears in more than one substance, you must keep them separate. Okay, so 2 plus 1, not 3. Alright, so working our way left to right and top to bottom in a methodical fashion, we have 8 doesn't equal 1. We can fix that with a coefficient of 8. This 8 goes up here. Every time we apply coefficients, right? So we coefficients to balance atoms, and then reinspect, which means we go back up here. Okay. So 8 equals 8 times 1. We put the 8 up here. We reinspect. This 8 also applies to the 2 for the oxygens. Right, we'll get to the oxygens in a moment. 18 doesn't equal 2, but we can fix that with a coefficient of 9. 9 times 2 does equal 18. We'll put a 9 up there. We reinspect every time we apply a coefficient. 9 was to balance the hydrogens, but it also applies to this oxygen, this guy down here. Now we get to the oxygens. Here's a couple other hints. When you have a uncombined element, such as O2 or H2, try balancing those last. And the reason for that is, if I apply a coefficient now to this oxygen, it's not going to affect any other compounds here because it's all by itself. And I should say an uncombined element such as oxygen or H2, try balancing last. It just makes life a little bit easier. Okay. Alright, so for oxygen, 2 oxygen atoms in the reactants. we have 8 times 2, that's a total of 16, plus 9. 16 plus 9 is 25. All right. 2 doesn't equal 25, so we need to apply a coefficient times the 2 to get to 25. And you can do this a couple of different ways. I'm going to do this algebraically. Right now we have 2, and we want this to equal 25. So 2 times something, put this in parentheses, 2 times something equals 25. If we divide each side by 2, that something is 25 halves. Right? Now you might be tempted to writing this as, oh, well, that's 12.5. But the problem is I can't put a 12.5 here, and I can't put it up here, because you cannot have 1/2 of an oxygen molecule. You either have 1, or you have 2, or you have 3, or you have 25, but you cannot have 12.5. So here's another trick or hint. Try applying fractional coefficients. This is what we have here. And this is just temporarily. So temporarily. Then multiply the entire equation, the entire reaction, by this fractional coefficients by its denominator. All right, well, the denominator is 2. So I'm going to apply this 25 halves. Right? Remember where we got this from. We had 25 on the left. 8 times 2 is 16 plus 9. Right? 2 doesn't equal 25. Well, that means our coefficient needs to be 25 halves. And if you notice this, right here, 25 halves times 2, the 2's cancel, and we get 25. We can do the same sort of thing up here. Apply the fractional coefficient 25 halves temporarily, and we're going to multiply through by the denominator, which is 2. But we have to multiply the entire equation through by this denominator. So what we get is 2 times C8H18, I'll write that up on top, 2C8H18. 2 times 25 halves, the 2's cancel, and I get 25 oxygens. 2 times 8 is 16 carbon dioxides, and 2 times 9 is 18 waters. Okay, so now this is equation is balanced. Remember, I had it balanced down here when I applied the 25 halves. Right? The 2's cancel. I have 25 equals 16 plus 9 is 25. 8 equals 8. 18 equals 9 times 2. So it's balanced. It's just a matter of getting it in proper form. Okay. So in order to do that, I multiply everything through by 2. And so long as I multiply everything by 2, the equality holds and it remains balanced. Okay, so I'm going to write an equation down here. We have sulfuric acid plus sodium nitrate. They react to give us nitric acid plus sodium sulfate. I'll put lines in front of each one here and ask you to try to balance this on your own. So pause the video, go through and try to balance this following those 4 steps. Always re-inspect after you've applied a coefficient, and when you're done with that, come back and I will quickly balance this and see how you did. So pause the video now. Alright, welcome back. Let's see elements. We have hydrogen, sulfur, oxygen. No, sulfate is exactly the same here as it is here, so I can simply write down the sulfate polyatomic ion. I've got sodium and nitrogen, and nitrate is exactly the same here in the reactants as it is in the products, so I can write down, whoops, I have sodium. It's supposed to be an A. Make this a bigger N. Here we go. Sodium and nitrate. All right. 2 hydrogens, 1 hydrogen. Sulfate, I have 1 sulfate, 1 sulfate. Sodiums, I have 1 sodium. Here I have 2. Nitrates, I have 1 nitrate. Here, 1 nitrate. So, a couple things about this first, as just a reminder. We never change the subscripts. We only apply coefficients when we're balancing a chemical equation. Sure, 1 doesn't equal 2 here, balancing for the sodiums. You cannot change this 2 to a 1, because if you remember, sodium is +1, sulfate is -2, and the reason that 2 is there is to balance the charges. So we use subscripts to balance the charges, and as soon as you start messing with that, the charges aren't balanced and it's all wrong. Okay, so only mess with the with the coefficients. So 2 equals 2 times 1. We use this to balance the hydrogens. Also applies to these nitrates down here. We'll get to those in a moment. 1 sulfate, 1 sulfate. They're balanced. This is balanced good. Sodiums, 1 doesn't equal 2. We can fix that with the 2 here. We use it to balance the sodiums. Also applies to these nitrates. 2 times 1 equals 2 times 1. So this is balanced. So let's double check. 2 equals 2 times 1. 1 equals 1. 2 times 1 equals 2. 2 times 1 equals 2 times 1. And the equation is balanced. And if you wanted, as we did in the homework online, you would need to add 1s here. So it's 1, 2, 2, 1. Very good. Let's try one more. I don't know how this one's... Well, no, that one's too difficult. Let's try... let's do this reaction. Hydrochloric acid plus calcium carbonate gives us calcium chloride plus water plus carbon dioxide. This reaction is actually very important as well. Calcium carbonate is one of the chief ingredients in cement or concrete, and carbonates, things that contain the carbonate ion, react with acids, hydrochloric acid in this case, to produce water, carbon dioxide, and a salt. Now the salt isn't the same thing as a calcium carbonate, and is not the glue that if binds things together, the cement that binds things together in concrete and brick and mortar and that sort of thing. And so this kind of reaction is this weathering reaction where concrete is essentially converted to water, carbon dioxide, and this salt, and then it deteriorates the concrete. But let's balance this. So we have hydrogen, we have chlorine, we have calcium, and we have carbonate. Now you don't, that's a polyatomic ion, but you don't see it here. You have a CO2, but not a CO3. So we cannot write the carbonate as simply CO3. It's got to be broken down, in this case, to carbon and oxygen. Alright, so pause the video here and try to balance this on your own, and when you come back we'll see how you did. Alright, welcome back. We'll determine how many atoms of each element. We have 1 hydrogen, here we have 2. Chlorines, we have 1, here we have 2. Calcium, we have 1, here we have 1, so not balanced, not balanced, here this balanced. Carbon, in the CO3, we've got 1 carbon, here we have 1 carbon. Oxygens, we have 3 oxygens here. Here we have 1 plus 2, so again, 3, it's actually balanced in this case. But that will change. Okay, so 1 doesn't equal 2, put a 2 here. This also applies to the chlorine. We reinspect. This 2 also applies to the chlorine. 2 times 1 equals 2. Oh, that's good. That's balanced. Calcium's 1 and 1. Carbon 1 and 1. And oxygen's 3 equals 1 plus 2. So is this balanced? That was pretty easy. 1, 2. Yep. All right, very good. A lot easier than it looked.